can we say that A is a multiple of B? Any idea? Factor. That's like active voice, passive voice here. If I'm asking you this way around, then you are giving me this way around. It's the same thing. When A comes in multiplication table of B, correct, Nihal? Simple. Whenever I can see A in the multiplication table of B, I will say A is a multiple of B, right? Or that is when I can say that A is equal to B into N, where N is a natural number. Or rather A, B, N. I'll say all three are natural numbers better. Actually, no. Let's say better N is a natural number because A and B can still be in decimals. I'll give you example. 4.8 is equal to 1.2 into 4. So N over here is integer, is a natural number. So thus I can say that 4.8 is a multiple of 1.2. 4.8 is the fourth multiple of 1.2. So the multiple and the factor term is also defined for decimals. Decimals, fractions, anything. Just the condition is the multiplying factor N should be a natural number. That's it. Okay? When can we say that C is a factor of D? When can we say that C is a factor of D? When D comes in the multiplication table of C, other way around, if I want to C to be called a factor of D, for example, say when can I say 8 is a factor of 72? So 72 should appear in table of 8. Then I will say that 8 is a factor of 72. Now this is active voice, passive voice. Okay? Now this I can write it as C is equal to D by N, where N is a natural number. C is equal to D by N, where N is a natural number. So that time I can say that C is a factor of D. Because if I take N to the other side, then I will get C into N equal to D, and then by definition, D is a multiple of C. So other way around, C is a factor of D. Okay? So these are inverse concepts of each other. And as I earlier said, that the logic can be extended to fractions and decimals also. Okay? Next. However, we usually talk about multiples and factors in the context of natural numbers only. We talk about multiples and factors in the context of natural numbers only. That's a general trend. It's not a compulsion, but it's a general trend. So any natural number will have infinite natural multiples, obviously, because multiples kabhi khatam nahi honge. Whenever you go for, say, 5 ka 1 lakh multiple, I will say go for 1 crore. When I say 1 crore, someone will say go for 2 crore multiple. When someone will say 2 crore, someone will say 20 crore multiple. This is endless. So that means the number of multiples that I have for a natural number are always endless. It extends up to infinity. But for any natural number, the factors are always finite. Because on a multiple side, I can go up to infinity. But when I have to come down, then I have a limitation. Right? Example, 72. Multiples of 72 would be infinite, but 72k factors would be very much limited. 72 can be written as 8 into 9, or it can be written as 12 into 6, or so many things like this, but limited. After a point in time, I know that it is going to end. Right? Natural factors I'm talking about are not general, natural only. So how can I write any number in its prime factor form? Now let's come to the important question that how can I write the number in a prime factor form? So for this, I need divisibility tests. And what are my divisibility tests? So I have a few numbers over here. The divisibility test is used to identify whether the given number is divisible by a particular number or not. So let's talk about divisibility test of 2. How can I check whether a given number is divisible by 2 or not? How can I check whether the given number is divisible by 2 or not? Right? कैसे कर सकते हैं? It should end with an even number. That means last digit should be 2, 4, 6, 8, 0. Correct? So can I say, in short, here the test is last digit should be divisible by 0. Last digit should be divisible by 2. Correct? Similarly, for 5, I can say last digit should be 5 or a 0. That's last digit should be divisible by 5. Last digit should be divisible by 5. Right? Correct, Pushkar. So next, what else can I say? 10 ke liye I can say it's very simple. Last digit should be 0. Which other do you know? Which other do you know? Do you know for 3? Test for 3? Yes, sum of digits divisible by 3. Sum of digits divisible by 3. 9? Same, sum of digits divisible by 9. Correct? Acha. What is the test for 4? Last 2 digits, correct. Last 2 digits should be divisible by 4. Similarly, for 8, what would be the test? For 8, what would be the test? Last 3 digits should be divisible by 8. Last 3 digits should be divisible by 8. Right? How about, acha, now look at the pattern. 2, 4, 8. 2 के लिए I check last digit divisible by 2. 8 के लिए 4 के लिए last 2 digits divisible by 4. 8 के लिए last 3 digits divisible by 8. So for 16, it should be last 4 digits divisible by 16. Basically, I'm talking about powers of 2. Right? I'm talking about powers of 2. So whenever I'm going for any power of 2, say 2 raised to 5, that's 32. So to check divisibility by 32, I should check whether last 5 digits are divisible by 32 or not. If last 5 digits are divisible by 32, then entire number, may it be 10 digit, 20 digit, 30 digit, doesn't matter. Just last 5 are divisible, then the entire number becomes divisible. Understood? So far with me? So far with me? Okay. Example, you can take any example, say 8719 512. Check divisibility by 8. So I will check only the last three digits. 512 is divisible by 8, so entire number is divisible by 8. Now before this, I can write another 3, 4, doesn't matter. I'll still check last three. So I can extend the number to the left to whatever digit I want. I will always check the last three. If that is divisible, entire number is divisible. Okay? Same logic can be extended to 32 Pushkar. Now you can try, if you wish, you can try. Last five digits, write down any number. For that matter, you can take this number. Check last five numbers. If they are divisible by 32, entire number will be divisible. Okay? What about 6? How do I check divisibility for 6? Okay, hold on, sorry. Before 6, एक काम करते हैं. Just a second. See, this much you know. This much you know already. Pushkar, if the answer is in decimal, that means it is not divisible. If the answer is natural number, then only I will say that it is divisible. Otherwise, I would say no, right? Acha. So far, I have seen test for how many numbers? 2, 3, 4, 5, 2, 3, 4, 5, 8, 10. That's it. इतने ही देखे अभी तक. Rest we'll see. Don't worry. Rest we'll see. I'll write again. We have seen 2, 3, 4, 5. और क्या देखा है? 8, 9, 10. And then others like 16 or 32 or whatever. Correct? These many we have seen. So now let's try to check the test for some prime numbers. Say for 7. Just a second. Huh? All right. So, as I was saying, let's check out for prime numbers. So for this number 7, now you guys need to remember these numbers if you want to remember the trick for 7. How does the trick works? Let's take a number for that matter. Chalo. Let's take a number 56732. Okay. 56732. What I am supposed to do if I have to check the divisibility by 7, I'll multiply. I'll separate out. First, I'll separate out the last digit and then multiply it by 5. Like this. See, last digit separated and then multiplied by 5. And then added back to original. So what do I get? What do I get? क्या रहा है calculation? 5642? No. 5 2s are 10. 5673 plus 10 becomes 5683. Sound lagging? Okay. See, what I'm doing over here is separate out the last digit, multiply by 5. Because here the number is 5. And then add it back to the original. So I get 5683. Repeat the process. Separate the last digit, multiply by 5 and add it with the rest. What do I get? What do I get? $583, correct? Repeat the process. Separate the last digit, multiply by 5, add it with the rest. What do I get? $73. After this, I can continue, or at this point also I can say that 73 is not divisible by 7. Thus, the entire number original, that is 56732, was not divisible. Or you can continue further. If you want, you can split it up further, 7 plus 5 into 3 and so on, you can continue. Okay. But it's okay. We know at this point in time that it is not divisible. So if it is not divisible, it is not divisible. That's it. Okay. Let's try again. Let's try this test, but now for 13. Rahul, yes, it is slightly time consuming, but these are some very odd numbers. So for these, the test would be like this only. Otherwise, if you feel that you're comfortable with direct division, then I would recommend do the direct division. These tests are going to be slightly time consuming. So whichever thing you're comfortable with. If you get comfortable with the technique, then do it. Otherwise, direct division option is always there. Okay. Now 13 ke liye, the number is 4. The corresponding number is 4. See, these numbers have been already worked out for you. So you just have to use them. So you need to remember 7 ke liye number was 5, 13 ke liye number was 4, and so on. So again, process is same. Separate the last digit, multiply by 4 now, and add it with the rest. Suryank, hold on. I'll tell you. So I get 5681, do the repeat process. I get 572, repeat. I get 57 plus 8, that's 65. And this is divisible. This is divisible. So I would say that the entire number 56732 is divisible by 13. Okay? Understood this? The logic part, have you understood? Okay. So now this number actually is called as a seed number. So the seed numbers here we have already calculated for you guys. The numbers would be like this. Here. You don't need to really break your head over it that how these seed numbers are coming in and what else and what not. So just keep it like that. And as far as your question was concerned, Suryank, what is the use of this tens digit? If the tens digit is not 1, then the first part which I'm splitting the number into, see, I'm splitting the number into 2 parts. Second part gets multiplied by 5. If the first number is not 1, if the tens number is not 1, then I need to multiply the first number by that thing also. Understood? Example, say for that agar yahan pe tens number was 2, then it's like 56732 mein I would have splitted it like 5673 and a 2, where 2 is multiplied by 3 and 5673 is multiplied by a 2. If this is 2, then this will appear over here, and then add and then proceed. That's how it will happen. Okay? But usually many big numbers won't be asked. You remember just these ones, that would be more than enough for you. More than enough. Okay? No, Pushkar, no such thing for odd numbers. Odd numbers के लिए whatever tricks I'm sharing right now, those are the only tricks. ठीक है? So this was about prime numbers so far. What about composite numbers? What about composite numbers? How should we check if a number is divisible by 6? Break it into prime. Very good. 6 is equal to 2 into 3. Break it into prime. Very good. 6 is equal to 2 into 3. So check for 2, check for 3. If both are there, then the number would be divisible by 6. How about 24? How should I split it? Yes, Surya, that is correct. The sum of digits divisible by 3 and the number should be, last digit should be divisible by 2. That's the test for 6. Now, how about 24? Okay. So now the concept of co-prime number comes in. So whenever you are checking for any composite number, the suggestion is you need to split the given composite number in terms of two co-prime factors. Two co-prime factors, such that co-prime means there is no common factor within the two numbers that you have split it into. For example, 24 you cannot split into 12 and a 2 as they have a common factor 2. 24 you cannot split in 4 and a 6 as they have a common factor 2. So how can you split 24? 8 and a 3. I want only two numbers. Neil, I want only two numbers. So I will split it in 8 and a 3. Split it into co-prime or relatively prime. It means the same thing, co-prime or relatively prime. 8 and a 3. No, Pushkar, check for 12 and 2. I already said, no. We have to split it into relatively prime numbers, 8 and a 3. 4 and 6 doesn't work. 12 and 2 doesn't work because they have a common factor. Okay? Similarly, I say 36. How will you split 36? Split 36 into two numbers such that no common factor is there within those two numbers. Nine and 2. Samath, 9 2s are 36. So how is that split of 36? I don't need the numbers necessarily prime. The numbers can be composite also. Just that they should not have a common factor within them. 9 and 4, yes. No, Nihal, 13 2s are 26. Tables, that's why I said tables. 9 and 4, right? So 9 and 4 do not have a common factor. So what should I do if I have to check divisibility by 36? Sum of digits should be divisible by 9 and last two digits divisible by 4. If both conditions are satisfied, then the number is divisible by 36. Otherwise, not. 117. Can you tell me what should I do for 117? For 81, will it be same as 3 and 9? No. Acha. Sum of digits should be divisible by 81. Not really. It won't work because sum of digits you will go up till what? So for example, if I'm talking about say number 81, is 81 divisible by 81? If I decide to apply the test, I would say sum of digits 8 plus 1 is 9. 9 is not divisible by 81. So would you say 81 is not divisible by 81? No. See, the sum of digits is a very, you can say, relative term. Because sum of digits, I am splitting it down into single digits. So using that, I can find out divisibility test only for one digit numbers. I cannot extend this logic for 3-digit or 4-digit, sorry. I cannot extend this logic for 3 ka power 3 or 3 ka power 4 or something like that. Got it? Suryank, sum of digits by 9. Yes, so 13 and 9, this is how I'll split it. So 13 ka test, we know the seed number. Seed number was 4 and 9 के लिए sum of the digits should be divisible by 9. ठीक है? And so on here. We can continue. So let's practice some questions now. Try the first one. All right. So yes, it is divisible. Correct. Yes, Pushkar, that's right. So yes, Aditya, very good. Ravi, yes, all of you, yes, very good. Yeah. So it is divisible by 24 because last three digits 432 are divisible by 8 and the sum of digits is divisible by 3. But there is a trick for sum of digits divisible by 3 also. It's like I don't need to add all of them. So what should I do? See, what I'll do is I'll cancel out the summations which I already know are divisible by 3. For example, 9 gone, 6 is gone, 3 is gone. Okay. I know 2 plus 4 equal to 6, which is divisible by 3 again. So 2 plus 4 is also gone. 5 plus 1 is 6, which is divisible by 7. Divisible by 3. So 5 plus 1 is also gone. 7 plus 8 is 15, which is also divisible by 3. So that is also gone. So everything gone, remaining 0. So it must be divisible. Understood? I don't need to add them actually. Right? So likewise, I can club them in pairs. So 3 is there, 8 is there, both are there, 24 is there. Okay. Next. Let's try for this now. How do I check for 66? I need to check for 6 and 11. 6 is basically 2 and 3. So I need to check for 2, 3, and 11. 2, 3, and 11. Let's check how we can do that. So 2 definitely yes, last digit is even. How about 3? Acha, have we checked the divisibility test of 11? 11 का नहीं देखा ना हमने? Oh, I think 11 we skipped. ठीक है, 11 we'll see it in this question. Fine, not an issue. So you check for 2 and 3 first. Is it divisible by 3? Gone, gone, and gone. 2 plus 4 is 6. So 2 plus 4 also gone. So remaining nothing. So divisible, yes. Now let's check for 11. How do I check for 11? How do I check for 11? Add the number of digits at odd, go for summation of digits at odd places. And go for summation of digits at even places. And then take a difference of those two summations. So 9 plus 0 plus 2 is 11. 9 plus 9 plus 4, that is 13 plus 9, that is 22. And 22 minus 11, take a difference. I get 11. 11 is divisible by 11. So the entire number is divisible by 11. Okay. Got it? Go for the summation of digits at odd places and go for the summation of digits at even places. Summation of digits at odd places and summation of digits at even places. And then take a difference between the two. So the difference between the two came out to be 11. So that's why it is divisible. So 2 years, 3 years, 11 years. So entire number is divisible by 66. Are we clear with this? Are we clear with this? All good to go? Let's try this then. If a number is divisible by both 4 and 6, then it must be divisible by 24. Yes or a no? If a number is divisible by both 4 and 6, then it must be divisible by 24. No. If a number is divisible by 4 and 6, then at max what I can say is it is divisible by LCM of 4 and 6, which is 12. See, because 4 and 6 are not co-prime numbers. That's why the problem. See, 24 ke liye we used to check for 8 and 3, right? That is the reason why we used to check for 8 and 3. Since 4 and 6 are not co-prime, so it's like what will happen is 4 and 6 both are divisible by 2. So I'll separate out that 2. Then what I'm left with is a 2 and 3. Sorry, I cannot take it out from both places. So let's do one thing. So if I take 2 common from here, so I get 4 and a 3. So 4 and 3 at best, I can say that can give me multiple of 12. Right? Or even better way, chalo, ek aur kaam karte hain. 4 and 6, take 2 common from both the numbers. So here I'm left with 2, here I'm left with 3. So multiply 2 into 2 into 3. So I can say that it is divisible by 12. Right? So if my factors are co-prime, then my common number here will be 1. If my factors are not co-prime, then there would be some common factor. So whatever is common, take it common from both and then multiply all of them. You can say it is divisible by that number, but not more than that. Okay? Try this. Next one would be true for sure, because 24 will be split in 8 and a 3. Third, if a number is divisible by 5, then its square must be divisible by 25. True or false? True or false? It will be true, correct. Because if I say number is divisible by 5, let's assume 5k. When multiplied by another 5k, I get 25k square. Right? I get 25k square. So it is divisible by 25 then. Right? Fourth. 40 and 60, it must be divisible by 120. As I said, 40 and a 60. What's the best common thing that you can take out? 20 you can take out common. So here I'm left with a 2, here I'm left with a 3. So 20 into 2 into 3, that's 120. So I can say it is divisible by 120. Done? Clear? So I have to take common till a point that these two do not have anything common anymore. Okay? Can we go to next? Okay. Find the smallest and the largest relatively prime numbers, which is, sorry, find the smallest and the largest relatively prime numbers to n, where n equals 21. So what did I say? What is a relatively prime number that does not have a common factor with the other number? Relatively prime number is a number that does not have a common factor with the other number. Right? So say 21. 21 का factorization क्या होगा? What will be the factorization of 21? 3 into 7. Right? So that means whichever is the other number that I'm talking about, let's say smallest over here and largest over here. So in that smallest number, I cannot have a 3 or a 7 as a factor because that is already there in 21. So what can I have? If I cannot have 3 or a 7 as a factor, then which is the number that I can have? Smallest possible number. 1? No, because it is said greater than 1. I want greater than 1. I don't want 1. Again, which is the smallest possible number I can have? 2. Now 2 doesn't have anything common with 21. Correct? So 2. Also, The largest number should always be 20, as in one less, because any two consecutive numbers in general are always co-prime, as they do not have a common factor. Example, say 9 and a 10. Do they have a common factor, 9 and 10? Do they have a common factor? No. 15, 16, do they have a common factor? No. So any two consecutive numbers can never have any common factor. So 21 must be co-prime with 20. Less than the given number, so 20. 21 must be co-prime with 20. Right? Okay? Is everyone with me? Yes, no. Response seems to be a bit low, guys. You guys are understanding? All right. Repeat once again. Question didn't make sense. Okay. See, what they want is 21 is a given number. I want a number which is greater than 1, but smallest possible to be co-prime with this number. Co-prime matlab kya? They should not have a common factor. So, what is something that does not have any common thing with 2 and 3 and a 7? What is something that is smallest and does not have anything common with 3 or a 7? Smallest possible such number is 2, as it does not have anything common with 3 or a 7. And what is the largest possible such number which does not have anything common with 3 or a 7? Largest, but less than the given number. Right? Largest, but less than the given number. So, see which is the smallest possible common factor that I can have between any two numbers? Which is the smallest possible common factor that I can have between any two numbers? One, no. One, we do not consider as a factor. Well, we consider as a factor, but in this terms, no. Because one will always be common. Two is the smallest possible factor that can be common between any two numbers, right? Other than one, and we are not counting one. So, if I say that there are two numbers which are as close as possible, and both of them are divisible by 2. then what is the least gap between the two numbers? Say if one number is greater than 1 and we are not counting 1. So if I say that there are two numbers which are as close as possible and both of them are divisible by 2, then what is the least gap between the two numbers? Say if one number is x, then what should be, let's say one number is 20, then which is the other closest number to 20 which is also divisible by 2? Either 22 or 18, but both these numbers are at a gap of 2. So within a gap of 1, do I have any common factor? Say 20 with a 19 or 20 with a 21. Do I have any common factor? No. So least possible common factor ke liye I need a gap of minimum 2. So with a gap of 1, I can never have a common factor. Right? Common factor, when we say other than 1. So that's why any two consecutive numbers will always be co-prime. So 21 will always be co-prime with a 20. Got it? Clear now? Will 2 be co-prime for all odd numbers? Yes, Rahul, as they will not have anything in common. How about 420? 420 is equal to 420 into, let's factorize this. So I get 42 into 10. That is 42 is like 6 into 7 into 10. 6 can be written as 2 into 3. 10 can be written as 2 into 5. And there is a 7. So that's 2 square into 357. This is my prime factor form. 2 square into 357. Right? So let me look at the smallest possible co-prime to this. That means in the smallest possible co-prime, I cannot have a factor 2, 3, 5 or a 7 as they are already present in 420. So if I cannot have 2, 3, 5, 7, then what is something that I can have as a factor in the other number? 11. If I cannot have 2, 3, 5 or 7, then the next best possible thing that I can have is going to be 11. Next prime number. And largest would be what? Largest would be obviously one number less, that's 419. Can I say? Clear with this? Can we go to next question? All right. $90. Obviously, Nihal, they have to be different. Okay. So 90 के factors would be 9 into 10, that's 3 square into 2 into 5. So 2 into 3 square into 5. So that's like I can't have a 2 or 3 or 5. So smallest I can have is 7, and largest I can have is one number less, that's 89. So 7 and 89. Understood, everyone? Clear hai? All right. Now I'm going one step beyond this. I'm going one step beyond this. Now what do I want? Smallest and largest composite numbers, they are relatively prime. So in the earlier question, I was not bothered whether my selected numbers are composite or not. But now, after selecting the numbers, I also need to ensure that they are not composite. So how do I do that? How do I do that exactly? Let's take an example, 42. 42, what are the factors? 42 is equal to 2 into 3 into 7, correct? So when I'm looking for the smallest possible relatively prime number, which is also composite, so I cannot have a factor 2 or 3 or 7. So what is the least factor that I can have over there? If I cannot have a factor 2, 3, 7, then what is something that I can have? No. How can I have 4? 4 contains a 2. How can I have 6? 6 contains a 2. 11, okay. But anything less than 11, is it possible? 5, yes. 5 is not there in 42, so I can have a 5 over there. But problem, if I take 5 alone, then it would be prime. To make it composite, I need to multiply 5 with something, right? Because composite numbers need at least one factor other than 1 in itself. So I need to multiply 5 with something. So what should I multiply 5 with? Again, same restrictions are true. I cannot have a 2 or 3 or 7. Otherwise, there would be a common. So if I cannot have 2, 3, 7, then what can I have? 5 again. What is stopping you from taking 5 again? They haven't said any restriction that you cannot take 5 twice. So let me take 5 again. So if I take 5 again, it will be 5 into 5, that's 25. That would be my smallest possible smallest composite relatively prime number. Understood? Understood the smallest? All right. What would be the second smallest? Can you tell me? If I want to find out the second smallest number, how can I do it? It should be 5 into 11. The second smallest would be 5 into 11, right? That's 55. But 55 exceeds my given number and I cannot go above my given number. So can I say that my second smallest is also outside my range? If my second smallest is also outside my range, then the only acceptable value 25 would be the smallest, and the same would be the largest because it is the only possible value within the given range. So thus my largest would also become 25. ठीक है? All right. Vaibhav, the problem in taking 41 is I want composite and 41 is not composite. ठीक है? 41 is prime, so I cannot take. ठीक. So in the previous question, I went from higher number to lower number. That means my quotient earlier, sorry, my divisor earlier was 45, and then my divisor was 15 or 5 or 3. I'm going from bigger to smaller. What if I have to go from smaller to bigger? When I have to go from smaller to bigger, then there is a slight problem because I cannot write directly. Just say in the earlier question, I factorized that 45 and wrote it in terms of 5 or 3 or 15. Now that's not the case over here. I cannot factorize 7 further. But these numbers which are mentioned here, they have a connection with 7. Like they are multiples of 7, except for 3. What to do with that 3, we'll see later. But other two numbers, 21 and 49, they still have a connection with 7. They are multiples of 7. In the earlier question, I was looking at factors of that divisor. Now I'm looking at multiples of that divisor. So what should I do now? So what they have told me is n is equal to 7. A 3-digit number is exactly divisible by 7. So let me say it is 7k. Right? Let's say the number is 7k. Now I have to divide the number by 21. Can you tell me what is the connection between 7 and a 21? 7 3s are 21. Third multiple it is. That's all. Now tell me any number in the world. So by the way, here k should be a natural number, right? Because k is a quotient. So k should be natural number. So tell me any natural number in the world. If I try to write in form of 3, then what is my possible remainder? I'll rephrase. Any general natural number in the world, you divide by 3. What are your possible remainders? Pushkar, the value is adjusted accordingly. Your K would be like, maybe your K is 15 or 16 or 19. That makes my 7K 3-digit, like that. Okay? So my remainders are 0 or 1 or 2. Any general natural number in the world, if I divide by 3, my only possible remainders are 0 or 1 or 2. So can I say this K, which is also a natural number, should also be of a similar form? That means K, when I divide by 3, should give me a remainder either 0 or 1 or 2. So can I say my K would be like 3m or 3m plus 1 or 3m plus 2? Can I say any general number in the world? You just told me that if I divide it by 3, my possible remainders are 0, 1, 2. Right? So I wrote K like 3m, 3m plus 1, 3m plus 2. One of these three numbers would be K. Correct? So let's write 7 into this, 7 into this, 7 into this. So that means n is equal to this, or n is equal to this, or n is equal to this. See, it's like this. If K is equal to say 18, then this one is 3m. If K is equal to 19, then this is 3m plus 1. If K is equal to 20, then it is 3m plus 2. And if K is equal to 21, then I'll again call it as 3m. But I'll change the value of m over here. Here my m was 6, here my m was 7. But can be called as some multiple of 3, right? Value of m is not fixed. M can be anything. So if it is 18 or 19 or 20, it is like this. So if it is 21, 22, 23, it is like this, and so on. Right? So let's multiply them. We selected 3 because 7 3s are 21. Yes, that's correct, Samarth. Okay. So this one is actually 21m. First one is actually 21m. Second one is 21m plus 7. And third one is 21m plus 14. So that means if I divide the given number by 21, what is my possible remainder? My remainder could be 0, or my remainder could be 7, or my remainder could be 14. That means if a 3-digit number is divisible by 7, then if I divide it by 21, then my possible remainders are 0 or 7 or 14. Right? The shortcut to this is 7 3s are 21. So in general, remainders for 3 are 0, 1, 2. And since I'm multiplying it by 7, so 0, 1, 2 into 7, that is my remainders would be 0, 7, 14. Okay? So when I'm going from smaller number to bigger number, there is not a unique value that I can say, but there are possible remainders, not a single remainder. So that's why the word possible remainders. Okay? Yeah, for any 2-digit, 3-digit, 4-digit, 5-digit, the logic would be same. Here they have mentioned for 3-digit. However, the logic would be applied to any of them. ठीक है? Clear everyone? So keeping the same thing in mind, you tell me instead of 7, instead of 21, if I go for 49, then what would be my possible remainders? Yes, Nihal Samar, that is correct. So 7 sevens are 49. And in general, if I divide any number in the world by 7, my possible remainders are 0, 1, 2, 3, 4, 5, 6. But since it is getting multiplied by a 7, so my possible remainders would then be 0, 7, 14, 21, 28, 35, and 42. Because 0, 1, 2, 3, 4, 5, 6, that's it. When I divide the number by 7, 7 cannot be my remainder. So 0 to 6 are my possible remainders. Multiply each one by 7. Because it is multiplied by 7, like here. So these are my possible remainders. Surya, don't forget 0. 0 can also be the remainder. Actual answer of question, as in Pushkar, which question? The second question you are asking about? Yeah, question 25. Everything we are talking about question 25, but there are 3 cases. Question 25, case 1, answer is 0, 7, 14. Question 25, second case, answer is this. And question 25, third case. Question 25, third case. How should I do that? Question 25, third case can be solved using this. Because 21m is divisible by 3. So remainder 0. 21m plus 7. Out of that 21m part is divisible. So 7 divided by 3. What is the remainder? No, Pushkar. There are 3 cases. So second, 21m plus 7. 21m is divisible by 3. 7 divided by 3. Remainder is 1. And 21m plus 14. 21m is divisible by 3. So 14 by 3. Remainder 2. So my possible remainders are 0, 1, and 2. Right? Correct, guys? 0, 1, and 2. So these are my answers. First, second, third. All clear? All good to go? So can we go to next question then? Sure. Very good. Sure. All right. Now let's come to challenges. I think we should keep this question on hold because we haven't solved such type of questions. First, we'll look at HCF, LCM, and then we'll come back to this challenger. Just note it down at your end. We'll come back to challenger 1 later. Okay, try this one. Under the last case, we can assume any general divisibility for 3. Yes, we can assume that. However, see, the problem is my number n was given in form of 7. So the problem is I don't know how I can directly go for, multiples of 3. How do I connect it? This is 7. This is k, for which I have no idea. And k is not related to, 7 is not related to 3. So somewhere I have to connect that 3 to get a sure shot answer. So that's why I did, since I cannot change 7, So the only place where I can play with is k. So that's why I wrote k again in form of 3. So 3m, 3m plus 1 and 3m plus 2. And multiplied it by 7. And then rest as we calculated. General divisibility for 3, that is correct. Eventually the answer came out to be that. But the logic why I used 21 instead of 3 was this. Because the original number was given in form of 7. That I had to incorporate somewhere. Are we clear now, Leander? Rahul, what if the number in the question is not a multiple of the option? That's what we did now. So that will be 7 and 3 were not multiples, not factors of each other. They were not connected. So then what we did is we tried to find LCM of them or some common multiple between them. And then from there we'll check. Okay? So I had information about 7. I wanted information about 3. So I made all of them with respect to 21. That is 7 threes are. And then I calculated the rest. So what's the answer to this one? Can there be a perfect square whose digits exactly consist of exactly 4 ones, 4 twos, and 4 zeros in any order? Can there be a perfect square like this? Samarth, the question is saying that, for example, 1, 1, 1, 1, 1, 2, 2, 2, 2. The number could be like this, or my number could be like this, or my number could be like this. Any type of number would be there. Some random combination of 4 ones, 4 twos, and 4 zeros. Can there be a perfect square? That means can any of these arrangements, can it be a perfect square? Yeah, it's a 12-digit number, Samarth, correct. Kushi, you're saying no. Pushkar, you are saying no. Can you explain the logic why no? In this entire chaos of numbers, see, I don't know the order of the numbers, right? I don't know the order of the numbers. So there is a chaos over here. But in this entire chaos, what is one constant thing? Yes, Kushi, that's right. So what is one constant thing over here? In any of these arrangements, be it this, be it this, be it this, what is one constant thing over here? 1, 2, and 0? No. That's my definition. That's already given in the question. So what is some interpretation or what is some working that you have done and you have found out that there is this particular thing which is common in any arrangement? All are going to be 12 digit. That's my definition here. There should be 4 ones, 4 twos, and 4 zeros. So all have to be 12-digit numbers. So not read. Anything else? Starting with 1. Not necessary. I can start with 2 also. They have not said anything about that. Order can be anything. Sum is 12. Yes. Now that's a working that I have done. I can observe. See, no matter whatever be the arrangement, my digits are exactly same, just that they are getting rearranged here and here and here and something like this. So no matter in what, whichever pattern you arrange them, but the summation of digits is never going to change. So what is that summation of digits? summation of digits is equal to 12. And what is the information that you get from summation of digits? Where do we use it? Where do we use it? Divisibility test. Yes. So I know that these numbers will certainly be divisible by 3. But will they be divisible by 9? Will they be divisible by 9? No, because 12 is not divisible by 9, which means whatever is my given number in any order, let's say n is the number. So n is going to be a multiple of 3, but it is divisible by 3 only once. It is not divisible by 9. That means there is no more 3 in k. So when I try to take square root, let's assume k is a perfect square. Even in that case, my 3 would be left alone. So square root of this number would be like root 3 into k. Let's say k ka square root possible and k ka square root is, let's say, m. So even in that case, my square root would be root 3m. So that means a perfect square is not possible, because any number that is divisible by 3 but not divisible by 9 can never be a perfect square. Because if a number is divisible by 3, let's say the number is of the form 3q, then its square must be of the form 9q square. Correct? If a number is divisible by 3, then square should be divisible by 9. And if a square is divisible by 3 only, it's not possible. Agreed, everyone? So answer for this one would be no such square is possible. Does everyone agree to this, or there is any doubt? Explain again. Okay. Samarth, as I was saying, that summation of digits over here is 12, which means that the given number is divisible by 3, but it is not divisible by 9. The given number is divisible by 3, but it is not divisible by 9, right? So how can 3 appear in my factors? Let's say, let's take an example. Chalo, let's take an example, a number that is divisible by 3 but not by 9. So 3 into, maybe I can take 16. That is 48. Is it a square? 48, is it a square? No. If I take, say, 3 into 8, tab to definitely no. If I take 3 into, say, anything that is not divisible by 3, 3 into 7 into 7, is it a square? No. Because whatever you do, this 3 will be left alone. Whatever happens to this part, that's okay. That's a separate story. But in any case, this 3 will be left alone. So when I try to take square root, it will be in the form root 3. Unless there is another 3 over here. And this another 3 would mean that the number is divisible by 9. That's not the case. So that's why, yes, so that's why there can never be a perfect square which has 4 ones, 4 twos, and 4 zeros in any order. Understood? Great, sure. Okay. How many numbers from 1 to 1000 are divisible by 3? How many are divisible by 3, bolo? 33? No. 1000 तक जाना है, 100 नहीं. 333 direct. No formula needed. Pushkar, we can do it directly. because 1 to 999, there would be 333 multiples, as 999 is 3 into 333. That means there are 333 multiples of 3. 5, 200, absolutely right. There will be 200 multiples of 5, both 3 and 5. 66, yes. How I can find it out is 3 and 5 both, that means it should be divisible by 15. So divide 1000 by 15 and check the quotient. So 15, 6 are 90, remaining 10, again 6 are remaining 10. Again, 10 is the remainder, but 66 is my quotient. That means I have 66 multiples of 15 within this range. Now 3, but not 5. 3, but not 5. That means out of the multiples of 3, I need to remove multiples of 15. That's how I'll get 3, but not 5. So out of the multiples of 3, remove multiples of 15. So I get 267. Not needed, Samath. We can do it directly, yeah. Not needed. And 15, but not 30. So there are 66 multiples of 15, half of which will be odd, half of which will be even. So half of it will be divisible by 30, half of it will not be divisible by 30, because any odd multiple of 15 not divisible by 30, even multiple of 15 divisible by 30. So out of 66, 33 will be odd, 33 will be even. So answer 33. Direct, right? Clear, everyone? Fourth one again, 3 but not by 5. So that means out of all the multiples of 3, I don't need a multiple of 5. But out of multiple of 3, that means already it is a multiple of 3. And out of that, if it is also a multiple of 5, I don't need that. That is 3 and 5 both. That means multiples of 15, I don't need that. So out of multiples of 3, subtract multiples of 15. So 333 minus 66, that's 267. Clear, Nihal? Rakshit, fifth one, 15 but not by 30. Multiples of 15 are like this: 15, 30, 45, 60. So all the odd multiples are not divisible by 30. Even multiples are divisible by 30. So out of the 66, half will be odd, half will be even. So 33 are not divisible by 30. 33 are divisible by 30. So here I need not divisible by 30. So 33. Done? So all done. Can we go to next question? Sure. ये तो हो गया, चलो. How many numbers between 400 and 800 are divisible by both? अच्छा, question 4 को भी hold पे रखो. We'll do it later once we have done HCF LCM. What is the remainder when 3 raised to 3, 4 raised to 4, 5 raised to 5 is divided by 6,000? Yes, Priyesh, go ahead. So I want to divide 3 raised to 3, 4 raised to 4, 5 raised to 5 by 6,000. Let's do that. Priyesh, when I said divisible by 3, but not 5, that means out of all the multiples of 3, understand and listen carefully, out of all the multiples of 3, I don't need multiples of 5. I don't need multiples of 5 which are already a multiple of 3. That means 5 and 3 both. That means I don't need multiples of 15. So out of multiples of 3, I don't need multiples of 15. So 333 minus 66. That's 267. Okay? Clear? Okay, so how about this? Let's factorize the denominator. That's the best thing that we can do. So what are the factors for 6,000? 6,000 is 6 into 1,000. 1,000 is 10 cube. 10 cube is 2 cube, 5 cube. 2 cube, 5 cube into 6, that is 2 into 3. So 2 raised to 4 into 3 raised to 1 into 5 raised to 3. Okay? And above it is 3 raised to 3, 4 raised to 4, and 5 raised to 5. Cancelled 5 raised to 2, cancelled 2 raised to 4, cancelled 3 raised to 2. So my denominator completely got cancelled. Since my denominator completely got cancelled, it means that my denominator is a factor of numerator. If my denominator got completely cancelled, it means denominator is a factor of numerator. In that case, what should be my remainder? 0. Right? So remainder becomes 0. Okay? So that's a learning, Nihal. Read the question carefully. Okay? Can you please tell something is in the form of P or Q or Z? As in, I couldn't understand, Surya, what exactly you mean. Something is in the form of P upon Q upon Z, or P or Q or Z. Okay. Why don't you rephrase your question, Surya? All right. So meanwhile, I'm moving on to the other presentation, the part that we were supposed to cover today. Let's start with that. P divided by Q whole divided by Z. Surya, that's basically P divided by QZ. Denominator ka denominator. So those two denominators will get multiplied, and that will be P upon QZ. Okay, presentation is visible to everyone. Chalo, let's start then. Write in a prime factorized form. Right, in a prime factorized form. Okay. 400. How do I write it in prime factorized form? See, one, we had our school method, that is go on dividing by 2, 2, 2, 2, 2 every time, and then 3, 3, 3, 3, 3, and so on. That's okay, that's right. But now we need to save some time. So if we need to save some time, then what we should do is make use of the divisibility test and go for the highest number that you know that it is surely divisible by. Example, say I can write this directly as 10 square into 4. 10 can be written as 2 square. So I'll write 2 square into 5 square into 4 is 2 square again. So 2 raised to 4 into 5 square. Better? Rather than dividing by 2, 2, 2, 2, 2, 4 times and then 5 and a 5. Can I do it like this directly? Right? See, this would have been your school method. So it would have taken a longer time. Let's try this. So I can say this is 8 into 111. 111 is divisible by 3. So 8 into 3 into how much? 8 can be written as 2 cube, 3 raised to 1 into, what's this number? 37. Yes, correct. So this is my prime factor form then. 2 cube into 3 raised to 1 into 37. Right? Next. What should I do with this? So first of all, I can write down 10 into 3003, or 3003 could be written as 3 into 1001. So 10 can be written as 2 into 5 into 3 into 1001 is divisible by what? Use the divisibility test and tell me it is divisible by what? 11. Let me divide it by 11. What do I get? 11 का टेस्ट क्या होता है? Alternate digits. So 0 plus 1 and 1 plus 0. Addition is 1 and a 1. Difference is 0. So divisible. Divide by 11, I get 91. And 91 ka split, do you know? 91 is 13 sevens are. Right? So let me write it in form 2, 3, 5, 7, 11, 13. Got it? So if you observe carefully, this number 30030 is basically the product of first 6 prime numbers. 2, 3, 5, 7, 11, 13. First 6 prime numbers ka product is 30030. Rather, more than that, you need to remember this one. 1001 is equal to 7 into 11 into 13. I'm sure somewhere down the line, it is going to be useful to you. Remember this fact, 1001 is equal to 7 into 11 into 13. Okay? Chalo, next. Let's try to understand what is LCM, least common multiple. A visits a certain place after every 7 days. One day he meets B, who visits there after 10 days. So, after how long will they meet again? A is going to visit a place, say on day 0, both of them were there together. A is visiting after every 7 days. So A will be there at 7, 14, 21, 28, and so on. And B will be there at 10, 20, 30, 40, and so on. So when will both of them be there together? At 70 days. Why? Because my observation was this is multiples of 7, this is multiples of 10, and I wanted a number which is a multiple of 7 and a multiple of 10. I wanted a common multiple of both of them, right? Can you tell me when will be the second meeting and the third meeting? Second meeting would be there after 140 days, that is after another 70. Third meeting would be there after another 70, that is multiples of 70. Right? So basically 70 is the least common multiple, and then after that 140, 210, 280, 350 are the common multiples. Right? So in such situations, when we start together and repeat at a fixed intervals, we want to find out when they will coincide again. The answer will be the least common multiple of the individual frequencies, LCM. And what is LCM? Acha, uske pehle theek hai. Let's look at HCF also, and then we'll define both together. Say a class P has 36 students, class Q has 24. The teacher wishes to give a group assignment such that all the groups are of same size and have no common students and are formed within a class. What are the possible group sizes? If I want class P to be divided into certain number of students, what are my possible choices? I can split 36 students into group of 1 each. So 36 groups will be there. Or I can split them in groups of 2 each. 18 groups will be there. Or I can split them in groups of 3 each, 12 groups. 4 each, 9 groups. 5. Can I split them in groups of 5? No, there would be one left over. But I can split them in groups of 6 each. Then I can split them in groups of 9 each. Then I can split them in groups of 12 each, 18 each, or I can say entire 36 ka single group. That is also possible. So with respect to my 36, what are these numbers? With respect to 36, what are these numbers? Factors. Yes. With respect to 36, these numbers are called as factors. Right? Similarly, I can find out factors of 24 to split 24 into groups. So factors will be like 1, 2, 3, 4, 6, 8, 12, 24. So can you tell me what is the highest? Acha, first question, what are the possible group sizes? So group size could be 1 or 2 or 3 or 4 or 6 or 12. These are my possible group sizes as they are common in both. So these are my common factors, and highest common factor is 12. The highest common factor is 12. So if you observe carefully, basically all these are factors of 12 only. So whatever is my HCF, all the factors of HCF will be my common factors. And all those will be my possible group sizes. Right? So let's define what is LCM and what is HCF. So LCM is basically the least common multiple or lowest common multiple. That means a number that is common in both the tables, whereas HCF is the highest common factor. That is a highest number that divides both the numbers without a remainder. Highest common number that divides both the given numbers without a remainder. Right? So let's see some properties with respect to LCM and HCF. Given a set of numbers, their LCM will be greater than or equal to the largest number. Example, say I have been given two numbers, 4 and a 6. Then LCM of 4 and 6 will be greater than or equal to 6. As in the LCM can never be less than 6. Similarly, HCF can never be greater than 4. HCF has to be on this side and LCM has to be on this side. Understood? HCF can never be greater than the smallest one and LCM can never be less than the greater one. Okay? Is everyone clear with this first property? That LCM of any two numbers can never be less than the greater number and HCF of two numbers can never be greater than the smaller number. Is everyone clear with this property? Yes or no, guys? Okay. Pushkar, you can take any example, say 4 and 6. As I said, 4 and 6. What is the LCM? LCM is 12, HCF is 2. So HCF is less than the smaller number. HCF is less than the smaller number and HCF is greater than the greater number. At max, it can be equal. Say I say 12 and 24 are my numbers. Then 24 itself will be the LCM and 12 itself will be the HCF. But in either case, my HCF can never be greater than the small number and LCM can never be less than the greater number. So my LCM would be either here or on this side. Similarly, HCF would be either here or on this side. Clear now? LCM will always be a multiple of the HCF. LCM will always be the multiple of HCF. That is, say, example 4 and 6. I know HCF is 2, LCM is 12. Right? HCF is 2, LCM is 12. So observe 2 6 are 12. So LCM will always be a multiple of HCF. Yes, HCF is also called as GCD, greatest common divisor or highest common factor. They are exactly same thing. Now, knowing the LCM, we can find all the common multiples of a given number as they will be multiples of LCM. Remember our first question? After 70 days, they are meeting first time. Then next common multiples are 140, 210, 280, 350. That is multiples of LCM. Similarly, remember second question, highest possible class strength is 12. So then all the factors of 12 are my possible class strengths. So that means whatever are my factors of HCF, all of them are common factors. See? Now let's see how to calculate LCM and HCF quickly. Let's say we want to find out LCM and HCF of this. One method was, of course, your school method. Like you write 60, 90, and 120, then you divide by 2, you get this. Then you again divide by 2, you get this. Then you again divide by 2, you get this. Now it is no more divisible by 2, none of the numbers. So you divide by 3. So you get 5, 15, and 5. And then again you divide by 5. Sorry, again you can divide by 3 because 15 is still divisible. So divide by 3, you get 5, 5, 5. Now you divide by 5, you get 1, 1, 1, and that's it. So whatever you observe on this side is actually your LCM, right? 2 cube into 3 square into 5 raised to 1. That is your LCM. And HCF can be computed by same tech. Can HCF be computed by same technique? Yes. So I need to check here for the common factors, as in observe this and tell me that for which line all the 3 numbers are changing. So for this line, when I divide it by 2, all the 3 numbers are changing. Not this, because here 45 is not changing, 45 is not changing, 45 is, 45 is not changing. But after this, if I divide by 3, all the 3 numbers are changing. So this is a common factor. After this, no. Then last 5, yes, all 3 numbers are changing. So my common factors are 2, 3, and 5. So my HCF will become 2 into 3 into 5. That is 2 into 3 into 5. That is 30. Right? So my LCM is 30. My HCF is 30 and LCM is 360. Clear? Clear, everyone? LCM is LCM is 360 and HCF is 30. Right? So far with me, this is the school method, but just a second. Okay. So, as I said, this was the school method. So now, if we want to look for a better method, what we should do is prime factorize these numbers. So 60 can be written as 4 into 15, that is 2 square into 3 into 5. 90 can be written as 9 into 10, or it can be written as 15 into 6. So 15 into 6, that is 2 into 3 into 3 into 5. That's 2 into 3 square into 5. Then 120 can be written as 15 into 8. That is 2 cube 3, 5. So this is my prime factor. Now observe. If I want to find out HCF, find the highest common factor in all the, you can say, in all the prime factors. See. First they are calculating LCM. Okay. LCM must include all the numbers. So I'm looking for the highest amongst all. So tell me, in the above factors, what is the highest power of 3? Highest power of 3. Sorry, highest power of 3 is this. Highest power of 2. Highest power of 2 is 3, that is this. And highest power of 5. All of them are same, 5 raised to 1. So pick any one. So my LCM will be 2 raised to 3 into 3 raised to 2 into 5 raised to 1. So in LCM, I am looking for highest power. Similarly, in the HCF, I am looking for the lowest common power. That is, look at 2. What is the lowest common power in 2? 2 raised to 1. Lowest common power in 3, 3 raised to 1. Lowest common power in 5, 5 raised to 1. Now tell me, had it been 7 raised to 1, 7 raised to 2 and nothing, what would happen to my LCM? LCM, what would happen to my LCM? LCM would get multiplied by 7 square, but HCF, highest common factor, that would not change, because when I don't have anything to compare here, it's like 7 raised to 0. And then if I check in 7th column, what is the lowest power of 7? 7 raised to 0. So 7 raised to 0 is 1. That means I don't need to consider this for HCF. So then my HCF will still be the same. Clear now? So minimum 2s that I must have is 3, minimum 3s that I must have is 2, and minimum 5s that I must have is 1. So my LCM is this. And similarly, HCF takes highest common power, that is this. Okay? Clear hai everyone? How did we calculate this? So let's try again with a few more examples. Something like this. Find LCM and HCF of this. What should I do? Don't say take commonalities directly. Observation, here I have a 4 raised to 4 and 6 raised to 6, which are not prime numbers. So this is not prime factor form. So first of all, I need to convert that 4 raised to 4 and 6 raised to 6 into prime factor form. And then I need to go for the other thing. Sorry. So to convert this 4 raised to 4 and 6 raised to 6, I'll write it like this. Sure. So I'll write it like this because 4 raised to 4 is 2 raised to 8. 2 raised to 8 and 2 raised to 5. When I combine them, I get 2 raised to 13. 2 raised to 5 and 2 raised to 8 combined, I get 2 raised to 13. So 2 raised to 13 into 3 raised to 7 into 5 raised to 6. Okay? So 2 raised to 17 into 3 raised to 9 into 5 raised to 5. That is going to be my second one, because 6 raised to 6 can be written as 2 raised to 6 into 3 raised to 6. So increase 2 ka power by 6, increase 3 ka power by 6. So I get something like this. And now this is in the prime factor form. So now I can find out LCM and HCF quickly. Right? So what will be my LCM? No, not solve it. As in, you don't need to calculate the actual value. Write it in terms of powers only. So 2 raised to 17 into 3 raised to 9 into 5 raised to 6, the higher powers. And HCF would be 2 raised to 13 into 3 raised to 7 into 5 raised to 5. Correct? Understood, everyone? All right. So for any two numbers P and Q, the product of LCM and HCF equals the product of the numbers L into H. Equals to the product of the numbers, meaning P and Q the numbers, का product is equal to their LCM into their HCF. Let's take any example for that matter. Say my numbers are 4 and 6. So 4 into 6 is equal to 4 6 ka LCM we know is 12. 4 6 ka HCF we know is 2. So it is equal 24 and 24. Right? ठीक है. We can take this also for an example. LCM is this, HCF is this, and their multiplication. Achha, but this thing is true for two numbers, huh, by the way. So if you see their multiplication will be 2 raised to 3, 3 raised to 3, 5 raised to 2. And again here also 2 raised to 3, 3 raised to 3, and 5 raised to 2. So multiplication of numbers is same as LCM into HCF. What happens if I have three numbers? So this is my LCM, this is my HCF. So by observation, there are still some numbers pending, right? This number is pending, this number is pending, this number is pending. So that means in case of three numbers, my LCM into HCF cannot match up with a product of the numbers. Here extra factors are left over. So that's why in case of three numbers, this property doesn't hold true. But for two numbers, the property holds true that LCM into HCF is equal to product of two numbers. Okay? With me, guys, so far? Okay. Now let's look at co-prime numbers. What are my co-prime numbers? Co-prime numbers are those which do not have a common factor. Co-prime numbers are those which do not have a common factor. As in, for example, 9 and 10, 10 and 11, 15 and 16, or maybe say 15 and 32. The numbers which do not have a common factor are called as co-prime numbers. Now the numbers are not necessarily prime in itself, but together the pair will be called as co-prime since they do not have a common factor. Now since they do not have a common factor, their HCF would be 1. Let's say A and B are such two co-prime numbers. So their HCF will become 1. So can you tell me what would be their LCM? A and B are such two co-prime numbers, then product, yes. Because A into B should be equal to HCF into LCM. HCF is 1, so the product should be equal to LCM. Correct? So A into B. Since the HCF is 1, LCM of the two co-prime numbers will just be the product of themselves. Now computing LCM and HCF. Now there is another way to calculate LCM and HCF of two numbers. Say I have to find LCM and HCF of 30 and 48. What I can do? First find out HCF by observation. Nihal, hold on to your query. We'll come back to it in some time. If I don't come back to it, remind me at the end of the session. So First, find out HCF by observation. Here, the HCF is going to be 6. I can see it. 30 and 48 have a common factor 6. Right? So, what I will do over here, let's see what is left over. So, leftovers are 5 and 8. Right? Leftovers are 5 and 8. When I divide them by 6, my leftovers are 5 and 8. Correct? So now LCM has to contain the common term as well as the individual leftovers. As in, my LCM will contain 6, 5, and 8. That is 240. Understood? So what I did, calculate HCF by observation, divide by HCF, calculate leftovers, and then common factor into leftovers will give me LCM. Okay. The logic is like this because HCF is, say, H. So A into H, B into H. H will be the HCF since I can take H common. So taking it common, so my LCM will be H into A into B. Okay? Next. Now this approach can be extended with some care to more than 2 numbers as well. That is 36, 45 and 54. Take common. What is the HCF by observation? HCF is 9. So what are my leftovers? 4, 5 and 6 are my leftovers. So remember, I will not directly multiply by 4, 5 and 6. What I will do? Find out the LCM of 4, 5, 6. As in, this is 2 square, this is 5 and this is 2 into 3. So there is still a 2 common over here. So in between 2 and 2 square, I should take 2 square if I want to find out LCM. 3 should be taken as it is, 5 should be taken as it is, and then whole to be multiplied by a 9 because 9 was my HCF. Okay, so this would be my overall LCM. Clear? Srinivas, I think this has answered your query already. HCF into leftovers, but as long as I'm talking about 2 numbers. If I'm talking about 3 numbers, then it should be HCF into LCM of leftovers. Because in 3 numbers, there might be still common in 2. Common in all 3, I have taken common already. But there might be common in 2. So to take care of that, I will say LCM of leftovers. Clear, Srinivas? Answer will be 540, yes. Yes. Now let's see how to calculate LCM and HCF of fractions. Simple formula is there, but to calculate LCM and HCF of fractions, the first and the foremost point that you need to keep in mind is reduce the fractions to simplest possible form. Reduce the fractions to simplest possible form. As in, 12 by 30 would be reduced to 2 by 5, 15 by 27 to be reduced to 5 by 9, and 21 by 15 to be reduced to 7 by 5. And then and only then the calculation can start. Otherwise, for sure, your answer is going to be wrong. So don't forget this most basic step. Reduce the fractions to simplest possible form. Okay? No, Richa, it's not really important to remember every trick. Whatever you can remember, that's okay. Whatever it's getting too much for you, you can just skip that part because the basic logic should always be there in your mind. As long as the basic logic is there, you will be able to calculate. Okay? If at all you can remember them, it's well and good. But if it is getting too much, that's okay. Skip it. Okay? So I get reduced fractions like this. Then after that, we'll use the formula. That is, in case I have to calculate LCM, it will be the LCM of numerators calculated separately. That is 257. Can you tell me what will be LCM of 257? 70. Very good. And can you tell me what will be the HCF of denominators? Highest common factor in 595. HCF, not LCM, HCF. That is 1, correct. So my overall LCM over here would be 70 by 1. Understood? So whatever thing I have to calculate, that thing should be done with the numerators and the other thing should be done with the denominators. Whereas if I want to calculate HCF, then it will be HCF of the numerators divided by LCM of the denominators. Okay. That is HCF of numerators. What is common in these? Nothing is common, so 1. And what is the LCM of 5, 9, and 5? 45. So we'll write 45. So 1 upon 45 is my HCF of fraction. Okay? Have we understood how to calculate LCM and HCF of fractions? Any difficulty in this? All right then, moving ahead. So let's try a question. Is this reducible? Any of these fractions, can I reduce further? No. Then let's calculate directly. LCM will be LCM of numerators. What is LCM of numerators? 4, 14, and 8. 56. By observation, I can do that. 56 will be the LCM. And what is the HCF of 3, 15, and 9? Highest common factor between these? 3. So this will be my LCM. And HCF will be highest common factor in the numerator. That is highest common factor in the numerator. That is 2. And LCM of denominators 3, 15, and 9. That is 45. So this will be my HCF. Hope everyone is with me on these calculations. Let me know if anyone is having a doubt. Good to go? All right. What if we have really large numbers? Roger that. Good here. What if we have really large numbers? See, one thing for sure, will rarely be asked LCM in this case, unless the numbers are in prime factor form. Because large numbers ka LCM would be much, much larger. So usually that's not the case. So if large numbers are there, then most probably HCF will be asked. For example, find HCF of this. So there is a trick to find out HCF of such larger numbers whose factors are not really known. Whose factors are not really known. So what should I do in that case? In such a case, any of these methods that we have learned till now would prove unwieldy because I don't know what are the factors. So what should I do? So here the observation is numbers are the numbers that are involved are close to each other. They are large, but they are close to each other. So let's use this. How? Let's take a relatively smaller example and then replicate this for the larger one. HCF of 70 and 90. How do I calculate? Divide the larger number by smaller, taking a note of remainder. Like this, 90 by 70. Can you tell me what will be the remainder? 20 will be the remainder, correct? So now what I should do is take this 70 over here and this 20 over here and get the remainder again. What's the remainder? The remainder now will be 10. Take this 20 over here and 10 over here. What's the remainder now? 0. So I have to repeat this process till the remainder becomes 0. I have to repeat this process till remainder becomes 0. And the moment my remainder becomes 0, whatever number is here, that becomes my HCF. Okay? The moment my remainder becomes 0, whatever number is present in the divisor part, that is my HCF. Okay. So let's try it for the bigger numbers that we checked earlier. That's okay. We'll not really need it to look at the logic, but let's look at this. 1397 and 1375. So divide. What's the remainder? What's the remainder? 22 is the remainder. So divide 1375 by 22. Remainder 11. Yes, 11 is the remainder. Now divide 22 by 11. Remainder 0. So that means my HCF for this question should be 11. Got it? It is time consuming, Pushkar, but can't help it here. Going beyond this, what else can we do? Otherwise, what we have to do is we have to do trial and errors and then check whether 1375 is divisible by 2, 3, 5, 7, 11, 13, 17. Where exactly am I going to get that? I don't know. Fortunately for you, here the 11 had a divisibility test. So you would have got the results as this is divisible by 11. What if the number was 17? Problem? So in that case, this method would be easy. Okay. Harsh, previous screen as in the logic or the 70 and 90 wala example? The logic part. Okay. Done? All right. If you don't have any HCF, if you don't have HCF, then it will continue till you get the last one as 1. You will continue till you get a 1 over here, as in your remainder will never be 0. Your remainder will be 0 only at the last step. That's it. Okay. How to divide 1375 by 22 quickly? Tables, Nihal. 22 6 are 132. So I know 132. So 137 minus 132. So I get 5, 55. So 44. That's 11. Okay. How many steps should we do till we get a 0? Surya, we have to continue till we get a 0 over here. Those many steps. And if we don't have any HCF, then how many steps should we do? We have to continue till we get a 0. See, ऐसा तो नहीं होगा that there is no HCF at all. If there is no HCF, then 1 will be the HCF. So 1 is HCF. That means you will still have to continue till you get a 0. So in that case, it will be like this, that you get a 0 over here, but this part is 1. Okay? What would be the HCF of 35 and 36? If you want, you can use the that logic now. See, 36, 35, 35, remainder 1. So take your 1 over here, 1, 35, 35, 0. So your HCF became 1. Understood? This is the case, Surya, where there is no HCF. So, but anyways, we have already seen this fact that any two consecutive numbers are always co-prime. That's the fact. Okay. And their LCM will thus be multiplication of the two. For LCM, no such trick can be found out. If you can find any, well and good here, share with me also. Okay. Let's try this. In a certain company, A visits the head office every 4th day, B 5th day, C 6th day. On a particular day, all three are present at head office. After how many days will all three of them be there together? Okay. When will they be there together? When will they be there together? LCM of 4, 5, 6, that is 60 days later. Absolutely right. How about this? How about this? 36 apples, 48 oranges, 72 grapefruits in a shop. Shopkeeper wants to pack all of them. HCF situation, but calculate the answer. I'll give you a couple of minutes. Try this question. All right, multiple answers. Let's see. So one thing for sure that this is clearly an HCF situation because there are 36 apples to be distributed in certain number of boxes. 48 oranges to be distributed in certain number of boxes, and there were 72 grapefruits to be distributed in certain number of boxes. Each box must contain the same number of fruits. That means I want a common factor that is there in all of them. So what is my highest common factor over here? HCF is equal to 12. Very good. So that means, so by the way, यहाँ पे पूछा क्या है? Each box contains this all. अच्छा, what is the minimum number of boxes? Okay. But HCF equal to 12 doesn't mean that every box contains 12. Every box could contain any factor of 12 also. It's like either all the boxes are of 1 or 2 or 3 or 4 or 5, sorry, not 5, or 6 or 12. All the boxes must contain either one fruit, or all of them contain 2, or all of them contain 3, or all of them contain 4, or 6, or all of them contain 12. Something like this. Now, if I want minimum number of boxes, then I should have maximum number of fruits in a box. If I want to reduce my number of boxes, then I should put maximum number of fruits in a box, and the maximum number of fruits that I can put in a box is 12. So let's put 12 fruits in a box. So how many boxes do I need for apples? 3. How many boxes do I need for oranges? 4. How many boxes do I need for grapefruits? 6. 3 plus 4 plus 6, total 13. So minimum of 13 boxes is what I need. Clear, everyone? Clear hai? Yes, no? Good, okay. Vishnu, we found out that HCF is 12. To have minimum number of boxes, I need to put maximum number of fruits in a single box. More the number of fruits in a box, lesser will be my number of boxes. Agreed? So if I put 12 apples in a box, then 3 boxes for apples, 4 boxes for oranges, and 6 boxes for grapefruits. So thus I got a total of 13. 72 by 12, 48 by 12, and 36 by 12. Clear hai? Next, 4 people have some chocolates. They try to divide, but one chocolate is left over. One more person joins them. They redo the division, and again one chocolate is left over. Yet another person joins them. Still one chocolate is left over. Then what is the minimum possible number of chocolates that they could have? Let's think logically about this question. That there were 4 persons. They tried to distribute the chocolates. One chocolate was left over. Then another person joined them. 5 people. They tried to distribute. Still one left over. Another joined them. 6 people. They tried to distribute. Still one left over. So let's say I am an outside observer to this group. So what I observe is every time that there is this one chocolate which is creating a problem, let me take away that one chocolate from them. Then they would be able to distribute it very evenly. Right? So what I did, I said, okay, that one chocolate is creating a problem for you. So let me have that chocolate. So they were happy to give it to me because then the distribution would have been even for them. So they gave me that one chocolate. Now, whatever is the number of chocolates left with them, is evenly distributable in 4 or 5 or 6, which means, can I say 4 is a factor of number of chocolates, 5 is a factor of number of chocolates, 6 is a factor of number of chocolates? In other words, can I say number of chocolates is a multiple of 4? It is also a multiple of 5. It is also a multiple of 6. So my number of chocolates should be a common multiple of 4, 5, and 6. So what is the common multiple of 4, 5, and 6? No, not 120. 60. LCM of 4, 5, 6 is 60. That means when I took away one chocolate from them, there were 60 chocolates left. But the chocolate that I took away was not mine to take away. So later on, I feel guilty about it. I said, "No, yaar, you keep your chocolate." So that means originally the group had how many chocolates? 61 chocolates. That means originally the group had 61 chocolates. Understood? By the way, technically this works for 1 also. That means had there been 1 chocolate, then 4 people, 1 chocolate left over. 5 people, 1 chocolate left over. 6, 1 chocolate left over. But that's just a technicality. We are not really looking into that because that means that I am not distributing any chocolates. I'm just keeping that leftover chocolate. That's it. So unless and otherwise there is something in the question that is pointing to this technicality, we'll ignore it. Okay. So clear everyone, how did we get this 61? So what I will say, if every time there is a common remainder, then what I will do, remove that common remainder. Then whatever is the remaining number should be LCM of the given numbers and then add back the remainder. So take LCM of the given numbers and add back the remainder. That would be your final answer. Acha. If not 61, can you tell me which is the next possible number? Then it would be 121. Yes. Yes, it's possible that remainder changes somewhat. We are coming to that. Not 122, Akshay. It is going to be 121. Because if not 60, then next common multiple is 120. So the group had 120 chocolates and I took away 1. So if I give back that 1, then it will be 121. Then next would be 181. Then next would be 241, 301, and so on. That is multiple of 60 plus 1. Okay? Acha. Now this is a question of changing remainder now. Let's see. 4 people have some chocolates. They try to divide the chocolates, but 2 are left. 1 more person joined, redo the division. Now 3 are left. 1 more person joined in, and now 4 are left over. What is the possible number of possible chocolates that they could have? Let's check. So 4 people, 2 left over. 5 people, 3 left over. 6 people, 4 left over. Here my remainder is not constant. Here my remainder is not constant. But still there is something constant. Can you tell me what is that constant thing? The difference between number of people and the chocolates left over is always 2. 4 minus 2 is 2, 5 minus 3 is 2, 6 minus 4 is 2. Difference between number of people and chocolates left over is constant. How do I make use of this fact? Again, me as an outside observer to the group, I was observing this whole scenario. So I said, let me give you a suggestion. I have 2 extra chocolates. I will give my 2 extra chocolates to you, and then you can distribute them. Let's see what happens. So in case number 1, there were 2 chocolates left over. I gave them 2 extra. So 2 plus 2 became 4. So 4 chocolates, they were happily able to distribute 1, 1, 1, 1 each. Case number 2, 5 people, 3 left over. 3 left over, I gave them additional 2. 3 plus 2 became 5. Each of them got 1, 1, 1, 1. They went home happy. 6 people, 4 left over. I gave them 2 extra. So 4 plus 2 became 6. So 1, 1, 1, 1. Each of them went home happy. Right? So that means when I give them 2 extra chocolates, then they are able to distribute the chocolates evenly. Right? So that means when I gave the group 2 extra chocolates, then the number of chocolates which were there was an LCM of 456. I know LCM of 456 is 60. So when I gave the group 2 extra chocolates, group had 60. But what if I had not given those extra 2 chocolates? Then how much would the group been having? 58. 58. Right? So here, what is my shortcut? So there are 2 types of problems. The one where my remainder is constant and the one where my difference between divisor and remainder is constant. So this is type 2, where the difference between divisor and remainder is constant. So what do I do over there? What do I do over there? I calculate the LCM of the numbers, and then whatever is the constant difference between the divisor and remainder, I subtract it from the LCM. LCM minus the common difference. And in the earlier question, I was doing LCM plus the common remainder. Okay. What is the next possible value? LCM minus 2 is the logic. So 60 minus 2. If not, then 120 minus 2. If not, then 180 minus 2. If not, then 240 minus 2. And so on. Right? Clear? All right. Just a second. Okay, I think we have done many examples. Let's go to questions now. Yeah. Too much of theory part. Let's go to questions. Chalo. Let's try this question. First one. 140 and 240. Find GCD and LCM. 140 and 240. Find GCD and LCM. GCD is 20, yes, and LCM is? So what I can do is prime factorize. So this one is 35 into 4, that's 140 is 2 square into 5 into 7, and 240 is 8 into 30 or 15, 16, that's 2 raised to 4 into 3 into 5. So my HCF over here will be 2 raised to 2 into 5, and LCM will be 2 raised to 4 into 357. 1680, not 17. 1680 it will be, Surya. Divide 140 by 240. Why so? We can do it directly. Now we have alternate methods, factorizing and all. See that dividing and remainder wala method for HCF, will use it only when the numbers are very large, factors are difficult, and we are not able to calculate using our normal methods. Then only we'll use that. Leander, can we use P into Q upon HCF? Yeah, sure, why not? So we can, LCM can be calculated like product of the two numbers divided by their HCF, that is 2 square into 5. So that's 20 basically. So 27s are. So 240 into 7 is going to be my LCM. That's 1680. Works. Okay? Second one. Is this your first session, Leander? All right. I hadn't seen you earlier in the comment section, so that's why I just checked. All right, not an issue. Which center, Leander? All right, all right. Okay. Chalo, how about this? GCD and LCM of 400 and 375. $25 is GCD, correct? So what I can do is, by observation, I can see that 25 should be my GCD. If I divide both the numbers by 25, my leftovers are 15 and a 16, right? So my LCM should be 25 into 16 into 15. And HCF should be 25. It's okay. We can keep it at that. No need to actually multiply and calculate. That's fine. In case you are calculating, it will come out like this. Next, try this. $48, $72, and $64. These are my factors, prime factor form. So HCF will be 2 cube, that is 8. And LCM will be 2 raised to 6 into 3 raised to 2. That is 576. Okay, you can keep it in this form. Answer in this form will also be acceptable to me. Samarth, check calculations. Yeah, go ahead. Ask all your doubts. Suryank, no, HCF is 8. Check again. 64 doesn't have a factor 3. How about this? Three large numbers. How do we use that trick? Which trick? That division and remainder wala trick? No, yeah, that can't be used for three numbers. So maybe what we can do is find out the HCF of any two of them and then check if that is the factor of the third or not, something like that maybe. But, otherwise, it's difficult to use it directly. Okay. 16 and 25. HCF is 1. LCM will be multiplication of the two, that is 400. See? Next. 28 and 308. Srinivas, similar type of question we have coming forward. So just hold on for that. I'm sure you will get the answer by yourself after we do that question. Okay? So 28 and 308. 28 is the HCF. And if 28 is the HCF, then LCM will be 308. Yes. Can you tell me why has this happened? That HCF and LCM are exactly same as the numbers? Because 28 is a factor of 308. Yes. So if such a thing happens, that is, if one number is a factor of other, then the smaller of the two is HCF of group and larger of the two is LCM of the group. Okay? Clear? Try this. This one also we know. Any two consecutive numbers, HCF is 1 and LCM should be product of the two, that is n into n plus 1. Next. I cannot use it in this form directly. So first I have to convert it into improper fraction. Tell me the conversion. What will be the conversion? 15 by 8. Yes. So 15 by 8 and 5 by 6. So then I have to find out HCF of 515, LCM of 68. And in case of LCM, I have to find LCM of 515, HCF of 68. So what will it be? 5 upon 24 and LCM will be 15 upon 2. Correct? Is everyone with me so far? So far okay? All right, good. Find GCD and LCM of these. 6 by 9, 4 by 12, 3 by 18. Yes, Surya. Two questions are purposefully kept. The challenges I think you made, right? So yes, those challenges will do it after we have finished all the questions in this part. Let's see, if we are not able to complete this presentation today, I'll not force push it. Whatever happens, happens. Whatever is pending, I'll cover it up in the next class, but I'll not rush through it. Okay? So first, cancellation. So my reduced fractions are something like this. Which are problem? Reduce nahi kiya. Am I right? Same. Yes, Nihal. Right. Pushkar, same problem. Reduce nahi kiya. You forgot the most basic step that I said. Reduce the fractions to the simplest possible form and then only proceed for calculation. No, Pushkar. Have you done reduction? So after reducing, the numbers are like this, and then I can go for calculation. So HCF will be HCF of 211 upon LCM of 336. That is 1 upon 6, and LCM will be LCM of 211 upon HCF of 336. That is 2 upon 3. No, Richa, still reduction is possible. After reducing, this is what you should get. Now you got it right, Pushkar? Okay, good. Okay, clear everyone? I'm moving on to next question. Okay? I have 132 oranges, 84 apples, and 144 guavas. If each type of fruit can be distributed equally amongst all the students in my class, then what could be my strength of the class? And what is my maximum possible strength? Can you tell me what kind of question is this? LCM type or HCF type? Okay. One very common question that I usually get, sir, how to identify whether it's HCF question or LCM question? My answer would be understand what I have to do over here. For example, here, do I have to look at the multiples of 132 or do I have to split 132 into smaller numbers? I have to split 132. When I have to split 132, that means I have to split it in terms of factors. So if I'm looking at factors of 132, that means I must be looking at the HCF. And if at all I was looking at multiples of 132, like 132, 264 and something, then I would have said that I'm looking at LCM. Okay? So that should be your hint. Try to understand that what are you doing with your numbers? Are you trying to find a multiple? Find any one of the numbers and then try to operate on that and check. Are you finding multiples or are you finding factors? If you're finding multiples, then LCM. If you're finding factors, then HCF. So what is my HCF? HCF over here comes out to be, no, 12. HCF comes out to be 12. So 12 becomes my maximum possible class strength. And what could be my class strength? All the factors of 12 are common factors. So that's 1, 2, 3, 4, 6, 12. Understood, guys? Anyone having a doubt in this, please let me know. Is anyone having a doubt? What could be, sorry, I couldn't understand your query exactly, Samar. Can you rephrase your question? Explain again, ठीक है? I'll explain again. HCF is 12. If they are asking for possible cases, then I have to look for all the common factors. See, all of you guys who said that you had a problem want me to explain again. Have you understood that how this is HCF question, or that part also is not clear? So what I have to do over here is I have to split 132 into my class strength. I have to split 132 into my class. So let's say how many students can I have? Can I have one student? Yes, I will give all 132 to him. Can I have two? Yes, half and half, 66, 66. Can I have higher than that? Can I have, say, 3? Yes. Can I have 4? Yes. Can I have 5? Can I have 5? No. 5 is a problem because when I try to distribute it in 5, 2 will be left over. Right? So that means 1 is okay, 2 is okay, 3 is okay, 5 is not okay, 6 is okay. So what are these with respect to these? So what are these numbers? Factors. 1, 2, 3, 4, 6 and all, they are factors. That means I am looking at factors. And my class 10 should be a factor of 132, class 10 should be a factor of 84, class 10 should also be a factor of 144. So I need a common factor of all. When I need a common factor of all of them, can I say, when I need a common factor of all of them, can I say that I need HCF? Common factor is CF. And when I want maximum possible class strength, I need HCF. So how can I calculate HCF? Factorize. 132 can be written as 2 square into 3 into 11. 84 can be written as 2 square into 3 into 7. And 144 is 12 square, that is 2 raised to 4 into 3 raised to 2. So look for the common part, your HCF will become 2 raised to 2 into 3. Okay? That is 12. So if my HCF is 12, then what is the possible class strength? All the factors of 12 will also be my common factors. Like 1 is there, 2 is there, 3 is there, 4 is there, 6 is there, and 12 is there. These are my factors of 12. 12 is the maximum possible class strength. But if I can distribute my fruits into 12, that means I can also distribute it in 6. Fruits ko double kar do. I can also distribute it in 4. Fruits ko triple kar do. I can also distribute fruits into 3 people, make the fruit 4 times, and so on. So these are my possible class strengths, and my maximum possible class strength is this. Now, are we clear? Yes or no? Okay. All right. Try this one. Find the least number which leaves a remainder 1 when divided by 18 or 24 or 30. Which logic is this? Should I take away the extra chocolate or should I give some extra chocolates? Take away or give? Take away wala logic. Every time there is a constant remainder of 1. So take away that 1 extra chocolate which is creating a trouble. So find out the LCM and then again give it back what you took. So find out the LCM and plus 1. That should be my answer. So what is the LCM of 18, 24, 30? I can sense 6 is HCF, take it common. I'm left with 3, 4, 5. LCM of 3, 4, 5 is how much? LCM of 3, 4, 5 is 60. And 6 I had taken common. So my overall LCM became 360 and plus 1. So my total number of chocolates are 361. Has everyone understood this? Clear? Eh? Okay, good. No? Why not, Pushkar? Remember that chocolate logic? Every time one extra chocolate is there, so what we do? Take away that chocolate, then remaining chocolates can be evenly distributed. So remaining chocolates must be LCM of 18, 24, 30, and then give back the one extra chocolate that you took away. So LCM of 18, 24, 30 plus 1, right? So LCM of 18, 24, 30, we just calculated. So what I'll do, take 6 common, I get 345. 345 ka LCM is 60. So 6 into 60, that's 360. 360 is the LCM and plus 1, so 361. Right? Don't look at this part. This part is just example. If you remember the earlier logic, then this much part should be good enough. Answer for previous question. Previous question kaun sa? Fruits wala. Nihal, the answer was 12, right? No, Srinivas. It's not the same logic because here the remainder is constant. The question that you are mentioning is more on these lines. Look at this question. Here my remainder is not constant. However, I know that when I divide by when I divide by 2, remainder is 1. When I divide by 3, remainder is 2. When I divide by 4, remainder is 3. So there is no constant remainder, but I can see there is a common difference between these. The common difference is 1. What do I do in this case? Take away or give? My logic is take away extra chocolates or give extra chocolate. Give extra chocolate is my logic. So what I do is give one chocolate each to the, give one chocolate to the group. When I give one chocolate to the group, then 1 plus 1 is evenly distributable in 2. 2 plus 1 is evenly distributable in 3. 3 plus 1 is evenly distributable in 4. So when I give one extra chocolate to the group, then the number of chocolates with the group will become LCM of 2, 3, 4, which is equal to 12. But I gave that one extra chocolate to the group. Had I not given that one extra chocolate to the group, then group would have been having how much? LCM minus 1. Because LCM में one chocolate is mine. ठीक है? So which is equal to 12 minus 1, that is 11. Clear? So now you understand the logic, Srinivas. In your question also, the difference between divisor and the remainder is constant. So use the similar logic, find the LCM, and then subtract the common difference between divisor and the remainder. Okay? Try this, and in case you still don't get it, then ask me the next time. Okay? Clear, everyone? Good to go? Okay. Will the difference be same in all the questions? Not really. So we have seen two types. Now, the one where difference is constant and the one where difference is not constant. Mostly the one where difference is not constant, sorry, I said something wrong. It's the one where remainder is constant and the one where remainder is not constant. The one where remainder is not constant, the difference will be constant. Usually the questions where difference also will not be constant will not appear in CAT, usually. Okay. If there are some questions, then at a later stage, when we complete our syllabus, so that time maybe we can look at certain questions like this. Okay. Additional practice like. Okay. All right. I think we should stop over here for today. Whatever are the pending questions uh, that we can cover up later. Okay. So next time, tomorrow we are meeting. So tomorrow we'll start with whatever is left over for today. But there is some homework, guys, that I want you to do. You guys have modules. In case you don't have the module, you can go to ebooks. Ebooks are available to everyone on my IMS portal. Go to chapter QA 1.2. In QA 1.2, class exercise. In the class exercise, whatever are the questions that we have not attempted today in the class, those questions you need to try once at home. I will be explaining them tomorrow, but before I explain them tomorrow, I want you guys to try, because now you are very well equipped with all the logic needed to answer these questions. Okay? So first you try, and then tomorrow we'll discuss them. Done? All right, so that's it then. We are done for the day. So in case you have any specific doubt, you can stay back and ask me. If you don't have any specific doubt, but you still have a suggestion or feedback to mention, please do so over here. And if not, then good night, take care.